Hello everyone. Welcome to our exploration of variable frequency drives, or VFDs. Discussing their role as soft starters, the frequency range they operate in, V/F ratio, how PWM works in addressing the notorious issue of harmonics. VFD as soft starter. Variable frequency drives, VFDs, serve as soft starters by allowing gradual acceleration and deceleration of electric motors, controlling speed through adjustable frequency and voltage. They minimize inrush currents, offer torque control, and enhance energy efficiency, providing a comprehensive solution for smooth motor operation and protection. A VFD receives power line input at 50 Hz. This is then rectified into direct current. The direct current is further filtered through a combination of an inductor and a capacitor. The frequency at which the voltage pluses are modulated in order to control the speed of connected motor. The carrier frequency of VFDs typically ranges from 4 kHz to 16 kHz. A higher carrier frequency results in shorter pulse duration, providing more precise control over the output voltage waveform. In variable frequency drives, V/F ratio typically represents the ratio between the output voltage and frequency. This ratio is crucial in controlling the speed of an AC motor. V/F ratio is crucial in maintaining the motor's magnetic flux. If the voltage is not decreased proportionally with the decrease in its frequency, the flux will increase. As the flux increases, the core will surpass its capacity to carry flux, leading to excessive heating. So V/F should remain constant. Let's understand this phenomena with the help of an example. Suppose we have a motor running at 440 volts, 50 Hz frequency. Now suppose if we decrease the frequency to half, then F equals 25 Hz and voltage remain constant. Here V/F increased, which will increase the flux, so core will not carry that flux and will cause excessive heating. So, with the decrease in frequency, the voltage should also decrease with same proportion. In above case, voltage will decrease to 220 volts. Hence the flux will not increase. If voltage decreased to half and frequency remains constant, so the V/F ratio decreased and flux will also decrease. Decreased flux means less magnetic field strength within the motor, which can lead to reduced torque production. The motor might need to draw more current to produce the same amount of torque, leading to increased losses and heat generation within the motor windings. Now let's study how PWM helps in maintaining V/F ratio constant. In the diagram we can see that as the frequency increases, the PWM increases the peak of sine wave by modulating the width of pulse, in other words, the duration for which IGBT allows the power to flow. The duration of the pulse affects the voltage. The IGBT gate trigger card drives IGBT gates, and hence power flows through IGBTs, resulting into a pulse width modulated wave that approximates a sine wave. Control card houses a microcontroller unit, MCU, which generates the signal to generate PWM pulse width modulated power flow in the IGBT. The signal from MCU card goes to the IGBT trigger card, which drives the IGBT. The IGBT, acting as a switch, can create pulsating waveform known as PWM waveform at a rapid pace. The switching rate of IGBTs can be controlled depending upon the desired output. Gate driver cards are isolated in VFDs to ensure safety, minimize interference, and maintain signal integrity. Harmonics in VFD and their disadvantages. Harmonics in variable frequency drives, VFDs, refer to the distortion in the electrical waveform that occurs when the VFD converts AC power to DC power and then back to AC power at variable frequencies. Harmonics are currents or voltages at frequencies that are multiples of the fundamental frequency of the power system. Harmonics in VFDs pose disadvantages, including power quality issues, equipment heating, interference with electronics, reduced efficiency, resonance problems, and potential non-compliance with standards. To control harmonics, filters are often used. Line reactors. By inserting a line reactor in series with the load or power source, it acts as a low-pass filter. It allows the fundamental frequency and lower-order harmonics to pass through while attenuating or blocking higher-order harmonics. Line reactors are relatively simple and cost-effective solutions for reducing harmonics. Harmonic filters. Harmonic filters are more sophisticated devices designed specifically to target and eliminate specific harmonics. They usually consist of a combination of capacitors, inductors, and resistors tuned to the frequency of the harmonic to be mitigated. These filters are more complex and expensive but can provide more targeted harmonic reduction. In conclusion, variable frequency drives are more than just speed controllers, they're the guardians of your motors. Understanding their soft starting capabilities, the frequency range they operate in, and addressing the challenges posed by harmonics equips you to make informed decisions for your system. Thank you for joining us on this journey through the intricacies of variable frequency drives. Until next time, stay curious.